Hey there, y'all. Today we're going to look at the second part of 6.1 on solving linear systems by graphing. And so we're going to look at this one word problem to talk about how word problems come together mostly the same each time we do them. Again, there's some variances and some nuances, but a lot of the word problems that we'll experience dealing with systems will come together in this type of method again, and we'll look at some different ones in class, but I want to show you this one particular example. So let's look at that. So in this second part of the lesson, our objective is to be able to write, graph, and solve word problems of systems of linear equations. Our standard still is AREI 6 to be able to solve linear equations algebraically and graphically, focusing on pairs of linear equations in two variables. And so let's take a look at this one problem. The admission fee to the state fair is $8 for children and $11 for adults. On a certain day, 2,300 people entered the fair and $22,000 is collected. How many children and how many adults attended the fair? And so when we're dealing with a problem like this, there's two separate equations that we're going to write. The first is based on the number of items. In this case, our items are people. And we're going to label this with variables that make sense. So children, C, and adults, A. So C is the number of children that attended the fair, and A is the number of adults that attended the fair. And so how many total people attended the fair? Well, 2,300, right? Well, so how can we write a statement knowing that we had so many children and so many adults attend the fair? Well, the number of children plus the number of adults has to equal to that 2,300. And then our second equation has to deal with the cost. Now, it's not always cost, but in a lot of these problems we're dealing with the number of items that we buy and then the actual cost of buying those items. And so this is where the $8 and the $11 comes into play. Because if there's only one adult who goes to the fair, I'm going to make $11, right? Because the adult ticket is $11. But if two adults go, now it's $22 because 11 times 2. And if I add in some children, we do 8 times however many children go. And so that's what we're going to write here. We're going to do 8C because 8 times the number of children that go plus 11 times the number of adults that go, A, is equal to the entire amount of money that was collected, so the $22,000. Now, this looks like a complicated problem to solve, but it's really not. We're dealing with two equations that are in standard form. And out of standard form, remember that we want to get our intercepts. And so we're going to have a C-intercept, and we're going to have an A-intercept. Now, which axis you put these on the coordinate plane is not going to matter in the end, but we need to keep track of which one's which. So the C, so C is equal to 2,300, that's for the first line, and A is equal to 2,300, because remember, when we're finding one intercept, we're plugging 0 in for the opposite variable. Okay, and so that's for the first equation. And so we're going to have to plot these on the coordinate plane, which means we need to number out our axes. And so this will be the number of children who attended. These will be the number of adults who attended. Now, on this graph, we've got 15 dots, and so we can count by every 200, for example. And so this would be 200, 400, 6, this is 800, 1,000, 1,200, 14, 1,600. This one will be 2,000. This one would be 2,400, 2,800, and the very top is 3,000. Now, 2,300 is right here, 2,300, and again, we'd have to label out our C-axis in this case. So 400, 800, 1,200, 1,600, 2,000, 2,400, 2,800. And so also my C-intercept is 2,300. Now we're going to have to do the same thing for the cost equation. And so again, our C-intercept and our A-intercept. So our C-intercept, 8C is equal to 22,000 Dividing by 8, we get that C is 2750. And then over here, 11A is equal to 22,000. So A is equal to 2,000. And so we'll plot those up. And so graphing our second line. Now, there's one thing we forgot to do. We forgot to connect these two lines here, those two dots. Now, doing the second one, we've got C is 2750, so that's going to be way out here at 2750. Dot there. And then A is at 2,000, so that's there. And so again, we want a nice straight line as we go to find this. Now, this is the problem with doing these by hand, is I found a point here, right? And it looks like it is at about 600, comma, about 1,700, okay? And 600 and 1,700 do give us 2,300 people, okay? We'd also need to verify that when we deal with these that, you know, it multiplies out. 8 times 600, 11 times 1,700. Does that come out to 22,000? We'd have to verify it to see. And so that's why when we're dealing with problems like these, our best move is to actually go to Desmos or use a graphing calculator and graph it that way and verify that answer that way. Now, that doesn't stop you from having to still write out all this work. Now, it wouldn't require you to find the intercepts because it'll graph it on its own. It'll graph the coordinate plane on its own, right? And you'll be able to see the intersection. But the biggest thing of the word problems is being able to write the two equations. And so that's the biggest thing. So after having gone to Desmos, we look at the picture that's here, and we see that my graph was not as good as it should have been, right? If you actually look at this blue, there's a bow in it, right? So it didn't get it nice and straight. Same with the red, there's a little bit of a bow in it. And so we missed the actual intersection. Using Desmos, we get nice, perfectly straight lines, and we see that the intersection actually happens at 1,100 and 1,200. And so what does this mean to the final answer? It means this, that the state fair had 1,100 children and 1,200 adults attend on this day. That's what it means in this problem. And again, we're making $23,000, so we have to take that into account for the final word problem. So that's it for this problem. If you have questions, make sure you ask them. But that's what we're looking at in this section, being able to solve and write these word problems. Again, y'all have a great day, and I will catch y'all next time.